This is a replay of the fourth webinar from the Heliple Federated PLM Interest Group hosted by Heliple 2 project. I'm going to talk about configuration management and how OSLC and STEP can play nicely in this area. I'll be demonstrating work done by myself and Andre to implement this in ShareSpace. But first, some clarification on what I mean by STEP. So STEP is ISO 10303 and it has many parts. So this presentation is concerned with the common features that are shared by all parts, and these are typified by ISO 10303-239 or PLCS, which is Product Lifecycle Support. And I'm only going to be talking about effectivity-based configurations. STEP has several different mechanisms for storing configurations. So the webinar content, I'm going to start with an overview of the methodology approaches of OSLC and STEP configuration management. And then I'm going to talk about some of the decisions that have to be made to get them to play nicely and follow that with the demonstration. First of all, there's no one-size-fits-all for configuration management methodology. Depending on where you are, there are different considerations. So it depends on the type and complexity of your product that you're trying to configuration and the type of business you are in. Certainly it depends on the engineering domain. Different types of engineering have different configuration management requirements, and also very importantly where you are in the life cycle phase of your product. So concept phases have again very different types of configuration management that you will then get to the utilization and support. Because of this, all approaches will need to play nicely with each other at some point. And so this webinar is really about how OSLC and STEP configurations can play nicely. Before we get on to the overview, whenever you see the icon, it means that the topic under discussion is my view or my opinion, and it's not necessarily the full specification. So starting with my view of OSLC configuration management, the targeted lifecycle phases for me are in requirements and application lifecycle management. It's handling explicit types of configurations, and it's very much to do with baseline. This is a schematic view of the OSLC approach for configuration management. The OSLC approach has streams and baselines. So streams, illustrated by these solid lines, these are mutable and for ongoing work. They link to the latest of whatever the artifacts are in that stream, and versions are hidden. So normally a user does not see them. You can merge changes from other streams or from baselines into the current stream. The baseline is a frozen record of a stream at a point in time. So when you link to artifacts, you are linking to them at the time of freeze. You can branch into new streams, and a stream or a baseline can be a contribution to other streams. So this is very much thinking of how it's done in Git repositories for software development. Now to look at STEP configuration management using effectivities. So in my opinion, these are typically used in the PLM to asset management phases of a product life cycle. And this shows some of the statistics of the type of complex products that are being managed in this way. It shows that there are thousands of unique parts with millions of occurrences of those parts included in hundreds of systems. And these need to be continuously configuration managed over many years. So these are typical statistics that are also encountered in the aircraft and automotive industry, as well as infrastructure industries like oil and gas or road and rail, or in complex buildings such as hospitals. So again, an overview of what is meant by STEP approach to configuration management. So in here, the links between things can be implicit, i.e. to the latest, or explicit, i.e. to explicit versions. So this is a different approach. There are two main aspects to this type of configuration management. The first one is dated effectivity. So every link and every property in the information can have a dated effectivity. So it has a start date, i.e. when did that become effective, and it can have an end date saying at this point this is no longer effective. There is then object effectivity, which I also is known as applicability, which is this little tick icon. So every artifact and every link can have an effectivity in relation to other artifacts. And these can also have conditions. So if there is no object effectivity, it implies that it's always applicable. But you could have an object effectivity, a link is only effective in relation to a particular object. And these object effectivities can also have their own dated effectivity. So your link can be effective for a particular artifact for a particular date range. So therefore now at any time or in the past you can filter to actually get what the structured artifacts are in the context of something and for a particular time. First, I'm going to give you an example of the power of dated effectivity using a simple component like a laptop. So imagine that the laptop initially has a disk in it that's actually fitted in January 2017. So this laptop's going to have some maintenance work done on it perhaps, and it's planned that there'll be a new disk inserted in May 2017. So we now got another relationship to this new subassembly of this laptop, but it's a planned relationship, it's not an actual relationship. Then when the maintenance goes ahead, you find that this disk was actually fitted in June 2017 rather than the planned date of May 2017. And when that is inserted, the original actual one now has an end date of the same time that the new one was fitted. So as you can see, if you look at different times over the life cycle of this laptop, you will see before June you will get the old disk, and after June you will get the new disk. So that was a very quick look at the main features of the two different approaches for configuration management. I'm now just going to list some of the incompatible differences from the end user's point of view for using these two different types of configuration management. First of all, looking at version resources in configurations. So in the OSLC configuration management, a version or a version resource is only in one configuration, whereas in the STEP configuration management, a version resource can be in no configuration management, i.e. it's applicable to everything, or it can be in many different ones, and you explicitly specify which ones it is applicable to, and you can also give it conditions. So it may be applicable to this one in this condition but not in another condition. So these two are very different, one to 0 to many. Then there's what configuration you're working in. Normally users of tools using OSLC type of configuration management, the user works in one configuration, whereas because of the nature of the STEP configuration management, the user can usually works in none, but they may work in one or many. So again, very incompatible from a user's point of view. Then a version visibility control. Often an application using OSLC types of configuration management, these are versions are often hidden, so the user may not see the versions, and any change they make normally creates a new version, and the old one is fixed, so you can't go back and change the old one. Whereas in STEP, the STEP series of standards, there is a thing which we call master version view. So there is a master object which has multiple versions and then multiple views, and there are business rules for when you change version. So the version is not linked to the changes. It's a business decision to when a new version is made. Then we get on to evolution history. So in the OSLC type of configuration management, so the user chooses when to make a baseline freeze. So they decide at this point, I'm going to freeze this and I will have that record. Whereas in the STEP types of configuration management, there is dated effectivity. So this is a continuous record of the changes over time for each resource, each link, and each property. Then configuration appointed time. So again, these are stored as baselines. So user chooses the appropriate baseline. And whereas the STEP side, there is, again, date and object effectivity. So a user chooses a date and they choose zero or many object effectivities and any conditions, and that will then show you what the configuration is at that point in time. And finally, links. So in OSLC, often the links are simple properties. So that's the default behavior. There is minimal use of link objects. There are some, but not much. Whereas in STEP, all the links are objects, and they may have effectivities, date and object conditions. They can have also other links, i.e. who made that link, was the link, has it got an approval on it, observations on it, events, object, activities associated with that link. So again, very different from a user's point of view. Brief overview of the different methodologies and approaches. I'm now going to start talking about, okay, they're different and we have to make some decisions for them to play nice. So the question is, how do we get them to play nicely? Well, you have to decide what is an acceptable compromise at the interface between the two different types of configuration management. And the answer is it's a business decision. How do we get these incompatible differences across the interface? So in Heliple 2, what we decided was we wanted to try and retain the full potential of both OSLC and STEP configuration management, and therefore not constrain the STEP type of configuration management to mimic what is done in OSLC. So what the compromise is therefore is that we expect the users not to be confused. So the users need to understand different approaches, and so when the response of one tool using one approach is different to the tool using another approach, they need to be not confused. And that was the compromise we had to make in order to get them to do the full potential of both OSLC and STEP configuration management. So what does that mean across the interface? So imagine you're in an OSLC environment and you're inviting the STEP configuration management to play. So what happens is that in OSLC, where you have this stream, which is a mutable change, what you need to do to get from the OSLC is, sorry, from the STEP is a set of object effectivities with any of their conditions. And you need to set the time to now, and then filter the information on the STEP side to give the structure or the view of the information. When you want to look at a baseline, again, it's the same. It's a set of object effectivity with their conditions, but what you need to do is provide the time at the time the baseline was created, i.e. the freeze time. And then when you, from the STEP configuration management, you will get the structured view at that time. Now to see how an application using a STEP-like configuration management might invite an OSLC configuration management to play. Because we want to retain the ability to add effectivity on relationships, we create an object in the STEP environment that knows it's a representation of something in another system. STEP has a mechanism for this, which is an external item. I'm greatly simplifying, but that's the general idea. Links inside the STEP-based environment to this external item can then have effectivities as normal. The external item has an object effectivity which points to the OSLC configuration management, and then it also has a resource URI. So if the configuration happened to be a baseline, then the same version is always returned when the information is requested from the OSLC based environment. If the OSLC configuration was a stream, on the other hand, then the latest version is returned. So before I go into the demonstration, I'm just going to give you a brief reminder of the previous webinars we've seen. So the first webinar, which was given by Eric from SAAB, was about the architecture and the Genesis model and why we are doing it. And so what we showed was a IBM DAWs acting as an OSLC consumer, talking to share a space via the Lynx Designer adapter. And what he was explaining was why we are doing it, and it was in an OSLC environment inviting STEP to play. The second webinar was given by Jad from LynxWork, and he was talking mainly about Lynx Designer, and what he was showing was how we are doing it, how we are getting OSLC to invite anybody to play. And what he showed was Polarian, which has got its own OSLC interface, and he was showing how you can use Lynx Designer adapter to put a OSLC interface or OSLC adapter on top of Jira. So it was mainly a focus on Lynx Designer, and he was showing how we can get OSLC to invite anybody to play. So for this webinar, we are showing how STEP can invite an OSLC configuration management to play. And so what we're doing is we have share a space, which is acting as the OSLC consumer, and we will be showing you how it will talk to another share space which has got a Lynx Designer adapter on it. It's going to talk to the Lynx Designer Jira adapter that we saw from the previous webinar, and we may get time to do some IBM DAWs next in Lynx. So we're focusing on STEP OSLC consumer and using share a space or share a space using OSLC resources, but we're using them in a normal STEP way. Okay, so we'll get on to the demonstration now of STEP inviting OSLC to play. The following demonstration is adapted from one given last November at a public webinar by myself and Simon Peterson. I encourage you to watch that to gain more insights into other types of configuration management, and you can see the links on the screen. I'm going to walk through a fictitious scenario touching on some of the capabilities needed for through-life configuration of assets, where those assets are complex systems of hardware and software. So for the demonstration, we're looking at a frigate class of ship and a fleet of individuals in that class, some of which are newer state-of-the-art build. So this frigate was originally designed for use in temperate climates, but the usage patterns changed, meaning that more often it's operating in hot climates. This means that the cooling and sprinkler systems have a higher utilization, and the pumps within those systems are experiencing more extreme usage pattern. This puts the vibration profile of those pumps outside the original design specification, and so leading to increased risk of failure, which is currently mitigated by a shorter maintenance interval and therefore greater downtime. Before getting into the resolution, I will show you what is in ShareSpace at this point. For ease of understanding, on the left I have an illustration of what we're looking at. It gradually builds in complexity, and for each new edition I will show how it looks in ShareSpace on the right. So what we're looking at here is that there are individual ships represented in ShareSpace, and each ship has an actual configuration for that ship. So first we're going to look at the structure of the ship class. So we're looking at the top level frigate design system, and you can see that it is a breakdown of a class, and it's a hybrid breakdown, and it's released. So for this demonstration we're just going to be concentrating on the just this breakdown and on the foam mist system within that breakdown, which contains the problem pump. I mentioned it's a hybrid breakdown, and you can see it starts with system elements, which are shown in pink on the left, and it breaks down into hardware elements, which are shown in blue on the left. In addition to the design breakdown, there is also an independent part structure. And so this shows the pump assembly, and for this demonstration we'll be looking or focusing on the motor controller, which is an assembly of both hardware and software parts. So now we're going to look at some of the links between the structures. So at any point in time, a breakdown element can be realized by one or more parts, and the realization relationship has its own set of metadata. So you can see in this view when the start date of this relationship appears. So that's the point at when this relationship is effective, and because there is no end date, it is still assumed to be effective. So this is saying that from this point onwards, the pump assembly design is used as the centrifugal pump in the system. As seen in the previous webinar, Jad showed creating an adapter for Jira using the Lynx Designer tool. We're going to be connecting to that adapter and using it to select a Jira bug. In OSLC, this is known as a defect, and in ShareSpace, it is a problem report. So when selected, the external item problem report is created in ShareSpace that knows it's a representation of an OSLC defect from Jira, and the view is displayed using the OSLC preview instead of the normal problem report information view that you get in ShareSpace. Back to the scenario, and it's been decided that the solution to the problem is to upgrade the pump by adding additional control software and hardware, and these will smooth out the operational extremes and therefore extend the interval between downtime for maintenance. But this is only possible on the newer ships in the class, which have the communication infrastructure already built in. So first, looking at the additions to the breakdown structure, focusing on the foam mist system, you can see there are now two children. There's the original breakdown at the top, and then there's the hybrid breakdown below. And when the new elements of the breakdown were added to ShareSpace recognized that the new element contained the original pump, and so consolidated the data rather than importing it again. So the new elements are, we've got some hardware elements, which are the control system with sensors and a control box, and there's also the control software which acts on the data and controls the pump. Similarly, there are also additions to the pump assembly. Again, when they were imported into ShareSpace, they were consolidated into the existing assembly. So here you can see a sub-assembly of the strain gauge and vibration sensor has been added to the two pump mounting points. And for this demo, it's only a simplistic space allocation representation has been added to the CAD geometry. A new part assembly has been added to the control system. This has some documents, so this could be data sheets for the controller, it could be user instructions or a user manual. There is also the subassembly of the controller software, and this is using the OSLC link. So what we've done is selected an OSLC part from, in this case, another share space, and you can see when you click on it, you see the preview of that part. I'm just going to break from the demonstration part and explain how we actually did that. So what we started with was the definition. So we started with Lynx Designer and we used it to model the OSLC domain for STEP, and then we updated the share space adapter. To use it, what we did was select configuration, use that to filter the selection, create an external resource, and then use that as if it was a normal STEP object. And then when you clicked on it, the OSLC preview to view it, and it can be used by other consumers. So I'm now going to go through each of those steps in more detail. So you can see here, this is the Lynx Designer modeling environment where we've generated a model of the STEP part, or a small part of the STEP definition for part, and it's got this next assembly view usage, which anybody who is familiar with STEP will recognize that. So what happens next then is that is used to generate the Lynx Designer adapter, which is then used on top of ShareSpace for ShareSpace to act as a server of OSLC parts now. And then the ShareSpace client talks to that. So now we've got the OSLC adapter for ShareSpace and OSLC client, ShareSpace acting as an OSLC client. The first thing that you do in ShareSpace is to select the configuration. So this goes and asks the ShareSpace server for the configurations, and this is this icon here, which we will be storing in our external item. So the next thing that happens is once that's selected, it filters the returned parts based on that configuration. Now ShareSpace also has also knows if you've already created one, so it produces this pop-up to say you already known this part in ShareSpace, so you don't need to create a link to it, and it will just reuse it instead. And then the final thing is, once you've selected this part, it creates the external item part in ShareSpace that knows it's an external resource, and so when you click on it, you get the preview over here in ShareSpace, and you can then click on the link and it will take you to that part in the other system. Got that external item part in ShareSpace, I can just use it as if it was any other type of part. So effectively, I've created this box here, and it's just acting like another one. So when I create the relationship, in this case, what I'm making is a child relationship from another part. You select it, and you can see that it's got a dated effectivity. And you can use it in all the other normal tools. So I can select this part, and this is a where used. So you can see that this part, which is the OSLC resource, is actually a child of this other part. Anywhere in ShareSpace, you will then see the preview in here. So this is looking from the parent in the assembly. You can see it's got the children, and when you click on it, you see the OSLC preview, which is provided by the OSLC provider. That OSLC provider is now available. It's not just ShareSpace that can link to it, but any other can link to it. And this just shows the doors next gen creating a references link to that same part in Eurospace. So back to the demonstration. As we saw before, the pump in the breakdown is realized by the pump assembly, and you can see this here in Eurospace. Continuing on, you can see that the software element is realized by the software part, and the sensors is realized by these hardware parts. And now what's interesting is that the single sensor system in the design system is realized by two parts in the assembly. Continuing on, you can see that the control box is realized by the control system, and again this shows now that the breakdown structure for the system is independent of the parts, because the siblings in this structure are realized by in different parts in the part structure. And then finally, we've got the software here is actually realized by the OSLC resource in the part assembly. As briefly mentioned before, all the relationships have a time element, a start time and an optional end time, and this means that it is possible to compare how the parts are changing over time. So this is showing the Eurospace comparison view of the pump assembly, showing that the sensors were added but since the specified time. And this is the sort of thing you can do to filter your structure given a time. So in addition to the time-based effectivity we saw earlier, relationships can also have an applicability to something. So far we have not included applicability, which means that the relationships are applicable to everything. In this scenario, the original faux misdesign breakdown is changed, so it's only applicable to the older ships, and the new design and new part structures are applicable to the newer ships. So this is a video clip showing you how it looks in Eurospace. So first of all, you select the configuration or the object applicability that you want to look at, and this was selecting the old one, and when you look at the design structure you just see now the old structure. If you now select the new variant of the class of ships, when you refresh the screen you will see the new structure. So that concludes the demonstration. To summarize what we've seen, we've shown how the STEP type of configuration management using effectivities work, showing object effectivity and data effectivity. We've also shown that you can include federated OSLC resources in this type of STEP-like configuration. And we've also shown that you can incorporate STEP constructs that are not already in OSLC. So you can use OSLC for other things than the existing domains. So now on to the conclusions. As I said right at the beginning, there is no one-size-fits-all for configuration management methodology, and therefore all approaches will need to play nicely. Federation allows this interaction while each play by their own rules, and OSLC is a working federation technology. So that concludes the replay of the Heliple 2 webinar for the Federated PLM Interest Group of the work done by myself and Andre. Thank you for watching.